Homework 3F. Okay, so this if statement right here. All right, so let's just stick it in BlueJ and see what we end up with. Okay, this might not be the one that I want. Let's close. Mostly I'm just looking for main statement, so I don't have to copy it is what I'm doing. All right, so this one will work well right here. So let's just go ahead and copy this code in. And we'll just do some slight manipulation to it so we can see what's going on. Well, maybe a little bit more manipulation to it to get it to line up all nice and pretty. Now see, that probably gives a little bit away, but this is lined up here, right? And the color coding in BlueJ actually helps you out a ton. Else if China location. Okay. So we've got this one, and so it sets a location equal to continental 48, and then it sets the country equal to China, and it sets the state equal to Ohio, and then it says if the string literal value of US equals whatever the country is. So we're looking at a literal value of US. If it equals the country, then if Alaska equals the state, so just ignore, we're doing some string literal values here. If Alaska equals the state, then the location is outside the 48. Else, if China equals the country, then the location is Asia. So we would expect that what the output is going to be is Asia, right? Because it's China. So let's do a print statement here and see what our output is. Systemout.println location. So let's compile. And I forgot my semicolon. I just finished teaching a class in Python, and they don't use semicolons in Python. So I get switching between the two languages is always a challenge for me. Okay. So we're going to go ahead and run this. And it says continental 48. So it's not telling me China, and it's not telling me outside the 48. It's telling me the continental 48, which is the default value. So that means that my location is set to continental 48, but I'm never hitting anything inside of any of these if statements, which is not what we should expect, right? I should expect that if I'm a United States country, then it'll check the state, and if it's China, it's going to tell me Asia, and I know it is China, so I would expect it to say location is Asia, but it's not hitting any of these, none of these if statements are true. And so what's helpful is let's put some brackets around here. So what happens in Java is if you don't include brackets, it assumes the next line belongs to the previous if statement. So we don't have any curly brackets in here, so it's going to assume for this if statement, this guy belongs to this if statement. And this belongs to this statement. And because there's no curly brackets, this belongs to this if statement. And this belongs to this one. So this is what it's going to assume because we put no curly brackets on here. So the only if statement that gets executed on the outside is the string literal US equal to the country, and because our country is China, these two are not equal. The rest of this never even gets executed. And so the problem we have is we're assuming, because the formatting shows this, that that's how things execute, right? That you're going to do this, and if it's false, you're going to come down here and do this. And that's not what happens. So what you have to do is you have to enclose this in curly brackets to force it to perform the way that you want to. So by enclosing this, now we've said this is our if portion, and this is our else portion. So let's compile this now and see what we get. And now we get our location is Asia. Oh, cool. Yeah. So this is what was happening here. It's just that we're missing the curly brackets to force it to perform, and assuming that the indentation is doing it for us, and it was not. So that would be why for me, I just always include the curly brackets. I never go without the curly brackets just to ensure that my ifs are always performing the way that I want them to. What else do you got? Well, let's take a look at the mini lab. So for this mini lab, you're writing your decoder ring. Okay, so for lack of a better term, so you just have to kind of think of, like, I don't know if when you were a kid, if you wrote, let me just make sure I'm recording this. I'm pretty sure I am, but just to make sure. Yes. Okay. I don't know if you, as a kid, created like a secret code with your best friend or whatever, where you wrote out the alphabet, and then maybe you put different symbols, like A is an asterisk and B is a this, or maybe you assigned them each of the letters in the alphabet a number or something like that. But that's essentially what we're doing here. Is that, I don't know if that rings a bell. I think it was even a little bit before my time, but they had what was called decoder rings, where you could plug in, if you have an A, you turn your ring to a certain dial and it'll tell you what the code is, that sort of thing. So this is essentially what we're doing here. Now, you're told, so what you want to do is you want to stick to what you're told. You don't want to try to assume anything. You don't want to add anything extra in there. You want to just stick to what you're told, all right? Default constructor. And we know a default constructor means empty parentheses, right? No explicit parameters with the default constructor. And it tells you that it initializes the offset to 0. Okay, we also know you have a single data field, data type integer, which is an offset. Okay, so you have one instance variable and that's it. And just a default constructor that's setting that instance variable equal to 0. You have a set and a get for the offset. So one is going to change the value of your offset. One is going to retrieve the value of your offset. So what the offset is it can be a value 0 to whatever. There's no limitation on how high that number is. But let's say that initially A is a value of 0 and B is 1 and C is 2 and so on. If our offset is 10, then what we do is we add 10 to each one of those. So A becomes 10, B becomes 11, C becomes 12, and so on. So that's the whole purpose of the offset. Okay. So the offset, if in the set offset method, it's going to take in one explicit parameter, which is the value of the new offset, but the offset has to be positive. Has to be a positive whole number. If a negative number is passed in, then the offset is not going to be changed. So to test that, what are you going to have to do when you're testing this particular set method? You're going to need at least 2 test cases. So what would those test cases be? definitely need to give it a negative value and make sure it does not change. You don't need to worry about the null because this is a number. You need to give it a positive number and make sure it does change, and then give it a negative number and make sure it doesn't change. So you want to test like we have been all along, where you actually give it a number and you expect it to change, but then you need to give it a negative number and expect it not to change. So let's say you create your object so you know your offset is a 0, so then you pass it a value of 6, you would expect it to be changed to 6, and then let's say then you pass it, you call the set method giving it a value of -6, you would expect the offset to still be 6 because it wouldn't change it. 6 and 6 might not be. Let's say it's 0, you change it to 10, so you expect it to be 10, then you give it a -4, you would expect it to still be 10 because the -4 should not have changed it. So you need to test both of those. Okay. And then you're going to have this method here, this getCode method. It takes in one explicit parameter of the string, which is your character. So it's going to take in an A or a B or a C or whatever is your letter of the alphabet, okay? And it's going to return to you the equivalent numerical code for that letter, all right? So, and here's the values. Each letter A through Z is assigned an integer value 0 through 25. So A is 0, B is 1, C is 2, D is 3, clear up through Z being 25. Okay? You're going to take the integer for the explicit parameters defined by the previous line. You're going to add the offset to it. So if you have an offset of 10, A becomes 10, B becomes 11, C becomes 12, Z actually becomes 35. However, the next line says any numbers greater than 25 should wrap around. So Z is not going to be 35. It's only actually going to wrap around, and it would become, 0. It would actually become 9. Z would become a value of 9 because you're going to wrap around to 0 up through, so it'll become 9. Okay? Any character other than A through Z should have a code of -1. All right. So some of this stuff is pretty straightforward. The hard part is this wraparound, right? So it's easy enough to say, is this character not an A through Z, return -1, right? So you can do that. Knowing what value each letter has, it's 0 through 25, that's pretty straightforward too. Adding the offset to the value, that's pretty straightforward. It's that wraparound part. So you can't just subtract or do whatever, because my offset could be 100, or it could be 400, or it could be 4, or it could be 7, right? So you have to take into account all of that. And they actually tell you down here. So they're saying, for example, if the offset is 20 and the character is Q, then you start by finding the corresponding number for Q, which is 16, right? You add the offset to it. 20 to 16, you get 36. This is beyond 25. It wraps around. So we're tempted to go 36 minus 26 equals 10. But what you need to do is, it tells you right here, consider using the modulus, dividing the character number plus the offset by 26 to give you the remainder. So think about that. If our offset is 0 and we have a C, which is a number 2, right? 2 divided by 26 is 0, remainder 2, and it gives us a value of 2. Now let's consider a Z, all right, which is 25, and we have an offset of 10. So 25 plus 10 would be 35, right? 35 divided by 26 is 1, remainder 9, and it gives us a value of 9, which was what our wraparound value would be. If we had a value of 100, so 25 plus 100 would be 125, divided by 26 would be 4, remainder 1, I think, or remainder 20. I need to math that out. Let me just math that out. Okay, so it's 4 times 26, which would be 104, 25, so it would be 21. So Z would be 4, remainder 21, so our Z value would be 21. Okay. So you're going to just add the two numbers together, the number that goes with your character and the number with your offset, and then just divide by the modulus and return the answer given to you by the modulus. Now, so let's go back and think about, I'm just going to pull up Notepad so I can jot some things down. All right, so I know that I have a character coming in and I'm returning a number. So it's kind of like public, integer, get code, something like that. And then in here is string, letter, whatever you want to call it. Okay, so however you're doing it, right? And you got your open and closing brackets. So I know I've got a string value here and I want to check it, compare it against the letter A. What do I do if I want to compare it? So I want to check and see, is the letter equal to A? So how do I compare my letter to the value of a character A? So, I mean, there's a couple different things we've got going on, right? We have comparison operators. So we have the equals equals comparison operator. And then we had a bunch of methods, right? We had the dot equals method, the dot equals ignore case, and the dot compare to. So if I'm doing an if statement, which is if letter, is equal to my string of A, right? What one of those comparison type things am I going to use here? Equal, equal. So remember, when we're comparing equal, equal, what kind of data are we comparing? Yeah, it's a string data. So it's a little tricky there. So what you might do as an approach, so you can go ahead and put your response in there. Well, with your solution there, you're comparing A to A. And so we know A is equal to A, right? What is it that you want to check to see if it's equal to A? Yeah. So you could definitely do that, or you could do it the opposite way. It doesn't matter. And I would probably do equals ignore case, just so you don't have to worry about, did they enter an uppercase or a lowercase, and you don't have to check that. So I would probably set, some variable, whatever your variable is going to be, code value, right? Set it equal to -1 right off of the get-go. Let's assume that it's not a valid character. So I'm just going to set it equal to -1. And then you can do your comparison in here. So you could do it the way that you did it. So you can either do letter dot equals ignore case A, right? Or you could say if A dot equals ignore case letter. Both accomplish the exact same thing, right? It's exactly the same. And if it is A, then you can set your code value equal to 0. And you could even add the offset, this dot offset at this point. Okay, and then you're going to have to do the same thing for B and C and so on. So you're going to repeat this 26 times, 1 for each letter in the alphabet. Now when you get clear down to the end here, the first thing you need to check is that code value. Because if it's equal to -1, you just need to return it. Or you could even, well, actually you could do the whole computation here. You could say 0 plus offset modulus 26. I mean, you could do that right here. You could actually not even, you just say return. You don't even have to do the, you could just return this whole computation right now. And then when you get clear down to the end, you can just say return code value. Because if it hit any one of these, it'll return it automatically. And if it doesn't and you fall all the way to the bottom, you know you've got a -1 and you can just return your code value. Did I just confuse things by combining all those things together into one statement? So what you can do, so I just combined it together to save me some if statements, but you can definitely say code value equals 0, and then do the same for B, and then the same for C, and so on. So lots of lines here for every 26 times. And then down here at the bottom, you could just do an if code value, equals a -1, then just go ahead and return code value. Otherwise, you can add your offset to the code value, and then divide the code value by, the modulus 26 and return the result. Yeah, you're going to need individual. You don't have to. You can definitely have a whole bunch of else ifs if you want to, but you could just make these all their own if statement. If it's equal to A, do that. If it's equal to B, do that. Because the reality is it's not going to be equal to, if it's equal to A, it's never going to execute any of the other statements. So, yep, 26 individual statements. You should be able to just copy and paste and then put them in there. Yeah. Now, when we get a little further on, I'll show you how you can do this easier. But for where we're at in the class, this is what you got. The tediousness of 26 if statements. Yes. So you can actually put one bracket here, and then you could put a bracket there, like that. So it's a little bit, not quite as many lines, but yes, just to be safe. Now, to test this guy, you're going to have several different test cases, right? So the first test case you might have is just leave your offset at 0 and just test a couple characters, right? So you might test with an offset equal to 0, and then, call your get code, passing it A and expecting 0 to be returned, right? And then call your get code, so you would be something like an assert equals 0, whatever you have your object name dot get code A. Because if the offset's 0, you would expect A to give you this, and you could call it, it's always a good idea to test the boundaries, right? So give it a Z and expect 25, and then give it some other code altogether. Give it a percent symbol or something, something that's non a character, and check for -1. Then you're going to need to change. You're going to need to call the set offset and set your offset equal to something else, 10 or 20 or whatever. And then do all of these exact same things all over again, but with the appropriate values. So now we would expect 10 for A and 9 for Z and we would still expect a percent symbol to give us a -1. And then you might even do this one more time, setting your offset to some astronomical number like 100. And you need to compute out what would A be, what would Z be, and again, so you need to really test quite a few situations to make sure that it's correctly doing your want to. I mean, best case is to test every single character, but I don't expect you guys to do that. I will. I have my test cases are already pre-written to test this code, so I'll test every single character. So that's obviously the best way to go about it. But as far as your test cases, if you test at least these 3 situations, I would be happy with that. No, I mean, I would be happy. Definitely test 2 or 3 letters and then an incorrect, invalid character. And then definitely, you need to change your offset to something, test it with 0 and then change it to something other than 0 for sure. Or I will deduct points if you just leave the offset at 0 and you don't test the wraparound. And so I guess that's the other key. You don't want to just test like A and B if there's no wraparound. You will need to make sure that you're testing a character that causes the wraparound to ensure it's working correctly. Well, cool. I was going to actually wait. They've posted Lab 3 out to Piazza, but I was going to wait on that until next week. Just because you guys have till July 11th. I'm pretty sure that's what it said, which seems really long. I was thinking you had 3 weeks for, yeah, Wednesday, July 11th. Is that 3 weeks? It almost seems like 1, 2, yeah, 3 weeks, I guess. It is 3 weeks. So I was going to hold off because I figure with the midterm this week, with the homework you've got going on and the midterm this week, that I don't need to do a review of Lab 3 just yet. And I was going to hold off and do that next week. I don't figure anybody's going to start it this early anyway. Matthew, very few people do well on these exams, so I really appreciate that you're coming to these Q&A sessions and, you're turning your homework in on time. And so, grades are grades, and I know that everybody looks at them as being very important, but being able to, start putting together the material and having those aha moments. I mean, when it, at the end of the course, what it really, your grade doesn't always reflect what you've learned. You know what I mean? So I'm always telling students, did you learn, do you feel like you've learned stuff? Did you get, that's what's really more important than the grade itself. Right. Yeah. So, and you kind of want to go, nobody asks for my GPA anymore. And actually, after about the first, job after college, they don't even ask you for your GPA at this point. So, and I always laugh because my daughter, her undergraduate was what was it? I don't know, exercise science or something like that. And she went on to be a physical therapist, but she had to take chemistry and it kicked her butt, And so her advisor was saying, boy, I bet you wish, in your chemistry classes, you'd got a better grade than that. It kind of messed up your GPA. And she's like, are you kidding? I worked my butt off for those grades. I'm dang on proud of those grades. I earned those grades. And so I always think of that. It's like, hey, you know how hard you worked and you should feel proud of what you accomplished. So there you go. Oh, so the only other thing I was thinking is not as far as the homework goes, but as far as the exam goes. So increments and decrements. I don't know if you're very familiar with increments or decrements, but um, an increment and decrement is just a shortcut, yes. So there's a very important difference. So plus plus A is not the same as A plus plus. Okay, the result is the same when they're like this. So let's say A contains a value of 12. Let me bump this down a little bit. For both of these, the result will be, this is going to be 13 or 13, and this one will also be 13. However, if you're putting this in a computation, if the before and after is very important. So if I have A equals 12 and B equals 10, and I put that in a computation, C equals A plus 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 B, okay, versus C equals plus plus A plus B, the results are different. So what happens is if your increment is before your variable, you increment first and then you perform your math. If your increment is after your variable, you perform your math first and then you increment. So in this situation, the result is going to be C is going to equal to 22, A is going to equal to 13, and B, of course, will still be equal to 10. And this one, because the increment occurs first, C is going to equal 23, A is going to equal 13, and B, of course, will still remain equal to 10. So when you're looking at a computation, a mathematical computation, and there's an increment or decrement in there, you have to look at where that appears. If it appears in front of the variable, you do the increment or decrement first, and then the equation. If it appears after the variable, you do the equation first, and then the increment or decrement. So that's kind of the only, kind of weird thing about the increment and decrement. Yep. That's about all I mean, the only things I can think of that are kind of outside the ordinary with regards to the homework and the other. Anything else you can think of? Oh, yeah, no problem at all. I know that, by about the middle point of the course, especially if you're taking other classes, it's probably the weekends are spent on the other class. So I think I'm never going to pronounce this right, but Abhishek, I think he's kind of in a different window than everybody else. I'm not sure how you ended up over there, Abhishek, but I do see you over there. So Matthew, he's asking, I don't think you guys can see each other's chats, which is kind of weird, but he's asking a question about the calculate distance in meters. So I'm just going to help him out a little bit with calculating that distance in meters. So if you want to cut out, because I know you've already got your lab completed, then no problem whatsoever. Yep, you have a great week. Yep, and see you on Thursday. All right, Abhishek, are you still there? Somehow not able to type into your window, I don't think, so I'm hoping you can hear me. Oh, it said he left. Well, I'm going to go ahead and go over the calculate the distance in meters anyway, just in case he views the recording or comes back in. So. Okay, so the first thing in the calculate the distance in meters, the distance is actually calculated in yards initially, right? So because we know it's calculated in yards, we're going to need to convert it to meters. And we know we have this conversion factor. So this is the number of meters in a yard. So if we have yards, you're going to multiply the number of meters by this conversion factor in order to determine how many meters. So that's the first thing to keep in mind. Okay. We also know to calculate the distance in yards. We have a formula for that, right? So let me go ahead and bring up the Word document. I'm almost there. Okay. So we've been given the formula for calculating the distance in yards. The distance is here, and this is our distance in yards. And it does say it needs to be rounded to the nearest yard. So we know this is our formula to calculate the distance. So I should have left up my Notepad++. Okay. So if I take a look at this, the distance for yards, so the distance equals C subdistance, okay? And let's see if we have a value C subdistance. Which is 0.093. So I'm just going to call C dist times by the speed, okay, squared, times by the sine of 2 times by the loft. All right. So the speed was previously calculated. So we have a function to give us the speed. So our c dist is going to be a double value c dist, and that equals 0.0, is it 0.093? Yes. So we've got that value. Our speed squared is going to be whatever is the name of that particular function. So if we come back here, we've got one that calculates right here. Calculate yards per second. Okay, so our speed equals this dot calculate yards per second, right? And then we have the sine times 2 times the loft, and we know what our loft is, which is calculate loft, right? So our loft equals this dot, well, loft equals this dot calculate loft. Okay, so we've got our different parameters. Now to square something, you have to use the math function, which is math.pow, and then your value, and then the power. Okay, so you're going to need to call your this dot calculate and raise it to the power of 2. And then we've also got the math function to do the sine, so math.sine, and then we've got 2 times whatever our loft value is. Okay, so when we're all said and done plugging these values in, so we get our distance here, plugging in the value there, so we'll plug in our variable, we'll call the calculate YPS and calculate the squared in this. We end up calculating our yards per, or our distance in yards, right? And so then that gives us distance in yards. So we know that value. We have this dot distance. So we can call that method when we're in. So we know how many yards we have when this is done. So to get our distance in meters, we just need to multiply our number of yards by the conversion factor, right? So our distance in meters is equal to this dot calculate distance in yards times by our conversion factor. Okay, so whatever the name is of that constant that we have up at the top, it contains our now, what you're told, however, is we need to cast this and we need to round it. So we've got this, and this is likely going to have some decimal places because our conversion factor is out to many decimal places. And we want this to be an integer value because it's returning data type integer. Okay. So to cast something, you put the data type in parentheses in front of it. So if we have this distance in meters, we can cast it. Well, first we need to round this. So we might do our distance in meters equals math.round, and then what we have here. Okay, so we're going to round it. Okay. And then we're going to cast it. And so to do that, we would put integer in front of it. So we would do a return integer distance in meters. And that's how it would look to return it. So you're going to take advantage of the methods that you've already written. This calculates our distance in yards. Okay. Then once we know we've got that done, then we just call that method to get our yards and multiply it by our conversion factor to know our distance in meters. Then we're going to need to round it to round up or down, okay, accordingly. And then we want to return an integer value, and we do that by casting, by putting the data type that we want in front of our variable.